Have you ever looked up at the night sky and wondered about the darkness between the stars? Is it truly empty? For centuries we thought space was a perfect vacuum, but science reveals a different story. The void is alive with hidden fields and fleeting particles, far from empty. Understanding this cosmic darkness is key to understanding ourselves. This is not just a question for scientists, but for anyone who has ever looked up and wondered. So let us begin this journey, exploring the darkness from ancient thinkers to modern physics. Imagine we are on a spaceship leaving our solar system behind. The Earth becomes a tiny blue dot, the Sun just another star in the Milky Way. We travel into interstellar space, the vast, silent darkness between stars. The blackness is profound, the stars distant and silent. The distances are immense, thousands of years to the nearest star. This is the void, cold and nearly empty. Yet even here there are stray atoms of hydrogen and helium. Over millions of years these gather to form nebulae, cradles of new stars and planets. The void is not empty. It is the womb of the universe, filled with the memory of its own birth. The question of nothing is as old as human thought. In ancient Greece, philosophers like Parmenides argued that true nothingness could not exist. He famously said, "What is." For him it was a logical impossibility. You cannot think about nothing because the moment you think about it, it becomes something. Other Greek philosophers like Leucippus and Democritus proposed that the world was made of atoms and the void. The void was essential, allowing atoms to move and form everything we see. This was a revolutionary concept, the foundation of our modern understanding of matter. In ancient India, Buddhist philosophy explored the concept of sunyata, or emptiness. It meant that things do not have an independent, permanent self. Everything is interconnected and constantly changing. Emptiness is not a dark abyss, but the potential for all things to arise and pass away. For centuries these were philosophical debates with no way to test them. It wasn't until the 17th century that scientists like Torricelli and Pascal began to experiment. They created the first artificial vacuums on Earth, proving that empty space could exist. This shifted the question of nothing from philosophy to science. Let us fast forward to our time. What does modern science say about the void? When we look out into the vast expanse between galaxies, what do we see? For a long time we thought it was almost perfect nothing. But even here, there are atoms, and a thin, hot gas called the warm-hot intergalactic medium, or WIM. Much of the universe's normal matter is thought to hide here, and everywhere there's a faint glow, the cosmic microwave background, the afterglow of the Big Bang. Even in the darkest void, you are bathed in the ancient warmth of creation's first light. But all this matter is just 5% of the universe. The rest is dark matter and dark energy, mysterious, invisible, yet dominating the cosmos. So, what if we could remove everything? What would be left? Would we finally have achieved true, absolute nothing? The answer, according to our best understanding of physics, is no. What would be left is space itself. And space, or space-time, is not nothing. It is a physical entity, the very fabric of the universe. Think of space-time as a giant invisible trampoline. Massive objects create dips in this trampoline, and this curvature is what we feel as gravity. A planet orbits a star not because of a mysterious pull, but because it is following a straight line through the curved space around that star. This fabric can stretch and ripple. When two black holes collide, they send out waves in space-time like ripples on a pond. We have built incredible detectors that can now feel these gravitational waves as they pass by Earth. So, space itself is a dynamic stage, an active player in the cosmic drama. Let's go back to our perfect empty box. We have removed all matter and all radiation. We are left with only the vacuum of space-time. Is this vacuum calm and quiet? Quantum mechanics gives us a startling answer. It says that this empty space is a boiling, bubbling cauldron of activity. It is filled with what we call quantum foam, where pairs of virtual particles are constantly popping into existence. These particles are called virtual because they don't last long enough to be observed directly. They borrow a tiny amount of energy from the vacuum to exist for a fleeting moment, and then they pay it back. This is allowed by a principle in quantum mechanics called the Heisenberg uncertainty principle. It states that there is a fundamental limit to how precisely we can know certain pairs of properties like energy and time. For very short moments, energy can fluctuate wildly, allowing these phantom particles to appear from nothing and disappear back into nothing. Our journey into the void has taken us to the edges of the universe and to the smallest scales of reality. But there is another void that is much closer to home. It is the emptiness inside matter itself. Think about the chair you are sitting on or the hand in front of your face. It feels solid, but what is it made of? It is made of atoms. And what is an atom? For a long time we pictured it as a tiny solar system, with a dense nucleus in the center and electrons orbiting like planets. This picture is useful, but it is also misleading. The scale is completely wrong. If the nucleus of an atom were the size of a marble placed in the center of a giant football stadium, the electrons would be like tiny specks of dust flying around in the outermost seats. The rest of the stadium, almost all of it, would be empty space. The solidity you feel is not from matter touching matter. It is the result of electromagnetic forces between the electron clouds of the atoms. You are not truly touching your chair, you are floating just above it, repelled by a force field. So, the objects we think of as solid are in fact almost entirely empty space. We began with a simple question. What is nothing? We have travelled through space and time, from ancient philosophy to modern physics, and we have found that the answer is not simple at all. What we call nothing is not an absence. It is a stage, a substance, and a source of creation. The vacuum of space is not empty. It is filled with ancient light, hidden matter, mysterious energy, and a constant fizz of quantum particles. The void is not a dead end. It is the womb of the universe. This journey changes how we see ourselves. It can be unsettling to think of the universe, and even ourselves, as being mostly empty space. It can make us feel small and insignificant in the face of such vastness, but it can also be a source of profound connection. To know that we are made of the same fundamental fabric as the stars, to know that the emptiness inside us is the same emptiness that holds the galaxies. It reminds us that we are not just living in the universe. The universe is living in us. Our curiosity is what drives us to ask these big questions. It is what pushes us to build bigger telescopes and more powerful particle accelerators. We want to understand our place in the cosmos. The search for nothing is really a search for everything.